Last time we generated the custom RSP and RSP2 files for the GBM detectors using the RSP and RSP2 file generator script. Now it's time for us to select the detectors that we would want to include in our analysis. Now, in order to determine the detectors and the relative strength, we need something which is called the quick lookup file. We can get it from the data we have downloaded earlier. This one, glg lc all grb name. Let's go back. Let's open it up. Here we can see the light curves for each detectors. We can see that the N4 has the greatest counts per second, followed by N3, then N8, then N7, and then N6. And the rest we can just ignore because there is so much data in it. Now, this is one way of determining the detectors. The other way is to get the angular separation from the source and these detectors. For that, we can use ggburst. Let's open that up. Let's load our data from the directory. We have our desktop and this GBM RSPGen. This is the folder in which we have the new response and response2 files. Now we can see that N4 has 39 degrees separation, N3 has 40 degrees separation, N8 and N7 are relatively close, 42 and 43 degrees, and the B0 detector has 88 degrees separation. We also saw the same pattern in the light curves. The strongest was for N4, then N3, followed by N8 and N7. We usually do not take too much detectors, only 3. But since it is a high energy GRB, we can take 4, but for now we will just stick with the 3 detectors, N4, N3 and N8. So let's close this. Let's close this as well, and we will copy the detector files, response2 files for B0, N3, N4, N8, and the fit files as well. Okay, we will copy them and we will move them to LAT GBM analysis, and we will also copy the background PHA and response file for the LAT data and move it over here as well. Now let's start the RMFit software. Okay, first thing to do is to go to options and display on load. What this option does is that as soon as the data is loaded, it shows up its light curve, but we don't want that. We want to load all the data first and then look at them after. So let's load. Let's go to the fit filter, GBM, where it is, that GBM analysis. So we saw that the N4 was the brightest detector. It also had the smallest angular separation from the source. We will load that data first because we need to scale the data in BGO detectors or in any other detector according to the brightest detector when we will be applying the effective area correctness. Next, we will load the N3 and N8 detectors, and then the B0 detector. So let's open up these local files one by one. Here we have the N4 detectors. We know the time that we want it to be within 0.704 to 117.058. So let's go to select source and source interactive. 0.705, slightly larger than the lower bound because RMFit adjusts it to the lower bound automatically, and then 117.05, slightly lower than the upper bound because again RMFit adjusts it to the upper bound. We will then accept, click on the left part away from the axis, and we have selected from 0.704 to 117.06. The RMFit has rounded off 0.58 to 0.06, but it has selected the data correctly. It is just not displaying it here. Now, in order to constrain it energy wise, we need to toggle the view, and we will come here to the energy spectrum part. There are two ways of going about selecting the energy range. For a low energy GRB, we can just select from 8 kV to 1 MeV and be done with it, or 900 kV, be done with it. But for the high energy GRBs, we need to cut off the 30 to 40 keV part, because it corresponds to the K band emissions when data is downlinked to the ground, and we do not want that disturbance in here. So for that, we go to select source, source interactive. Again, we want the data to be from 8 keV to 30 keV and 40 keV to 900 keV. So we go for slightly larger and slightly lesser values, like let's say 8.8 to 29.5. As you can see, we have selected from 7.9 to 30 keV. To adjust the sources, to adjust the bounds, we can go to adjust source and then move the left selection a little bit. It has come to 8.82, which is fine for us because it is greater than 8 keV. Then we will do this again. We will go for 40.1 and then we'll go for 890, which it has scaled to 899, which is close to 900. Fair enough. When we toggle back again, now this is the trickiest part of making the lookup files, the background selection. It is highly subjective what looks better to everyone. So for me, when I see a straight profile in the GRBs like this one, I usually go for the polynomial one, and if I see a curved one or something else, I can do the background fitting with a higher polynomial. Now usually you need to leave some area from the borders of the source selected so that the source selection cannot contaminate the background sources. So we do it slightly from here to like this part, and from here we go from here to the end, and then we select the background polynomial to 1. This is the chi-square map for the fitting that has been done in the background. As you can see, it is almost centered around 1, so that's okay. We toggle it and we see that the spectrum and the background are of relatively same size, so that's acceptable. Now we save the lookup file. Saving the lookup file is important because it saves all the parameters for time constraint, for energy constraint, for the background fitting. And when you load it up again, you do not have to again adjust the size, adjust the parameters. That way, whenever you load the data, whenever you perform the fit, you get the exact same values for the models that you have done in your previous run. This is also important in a sense that it constrains the background. So whenever you load it into another detector file, the background selection will be the same. You might need to adjust the energy selection, but usually the background selection and the time constraints remains the same. Let's load up another detector. And 3, we load the lookup file for the N4 detector. Now as you can see, the time is again selected from 0.704 to 117.06, as I said earlier, and the background has also been selected here. The only thing we need to worry is the energy range, but we can see that the energy range is 8.7 to 908, which is close to 8 to 900 kV, so we can like let it go. Save the lookup file again and read the new lookup file back so we do not mess with the N4 lookup file. Here we can see we have loaded the N3 lookup file. Before that it was N4. It was actually reading the N4 lookup file. Close that, load the N8 detector, Again, read the lookup file, let it load, and look for the problems. We do not see any problem in time. Again, we again have considerably appropriate uh, energy range is 8.5 to 903, and we also have the background of the spectrum looking like the spectrum itself. So let's just save the lookup file and then read it back again. Okay, we have loaded the NAI detector file. Now for the BGO, the NAI and BGO detectors have different ranges. NAI is from 4 keV to 2 MeV, and the operable range is from 8 keV to 900 keV, while the BGO has the energy range from 100 keV to 5 MeV, with the operable range of 250 keV to 40 MeV. So when we will load the lookup file for the NAI detector, we will need to change the energy constraint at least. So let's go to file, lookup, read lookup file, and read the N4 file. Okay, we need to toggle, and we can see that the energy constraints are very bad. To restore the energy spectrum, we go to zoom and zoom out full range. To remove the selection, we go to source select, source interactive, and click on the rightmost side of the axis, and then the constraints are again normal to what it should be. For selecting the range, we go to source selection, again slightly larger than 250 and slightly lower than 40 MeV, and we have 250 to 40 MeV selection, which is what we wanted. We get toggle back again, we can save the lookup file, save, and then we can read it back again. Okay, we have read the B0 lookup file. So far so good. Now let's load the LAT data. For that, we change the filter to PHA, and we then display. Again, we need to select the background and we need to select the source. For that, we go to select background, we pick up the background file, then we select source and select to the last photon detected. Now this range, why we have excluded it? Because there is no data in it, but also there is also no data, so why have not we uh, removed that part? Well, usually we do not remove the part before the last photon selection, even if there is no data beyond that. Like if there is no data here, we will still select the data from 100 MeV to whatever this point is. We do not remove the data prior from the last photon detected. So we can also save the lookup file here, save lookup file. Okay, so this is it for the GBM data constraints in time domain, in energy domain, fitting of the background, loading the LAT data, loading the lookup file, saving the lookup files, etc. In the next video, we will perform the data fitting. We will fit several models on the data, and then we will see how they differ, how can we perform better fits, what we need to look out for, etc.